on site this morning. Ray's got the jackhammer and we're trying to get the rock out of this footing. How's it going? Good morning. Did we really volunteer to do this? We're finding that you have to become one with the rock and know exactly where the rock grains are going. And then once you get in those, you can chip off the pieces. Otherwise, you're just like drilling a hole in the rock and none of it goes away. In the case you didn't have a jackhammer, Jason's gonna demonstrate how you could do it like a real man. Yeah. All right, let me back in there.
Oh yeah, I got a piece.
So we got Max and Paul Bunyan here working on another rock section. And I would say that if the entire footing was like this, solid rock, we would consider not ground forming the footings. You see a lot of people in places where it's hard soil, just form up the footings with timber, like 2x8s or whatever, right on top of the ground, and then just backfill in around it so that your footings are below the soil in the end. And yeah, if the whole footing was like this, it would take just like a week to dig the footing.
We're basically done cleaning out the footings and it's time to put steel in, but we're gonna do a little bit more double and triple and maybe even more than that checking.
Quadruple checking.
I feel like the stakes are high out here. If I make a mistake, there's just huge implications both in time and in money out the window, and it'd probably be my money out the window, by the way. So I don't wanna do that. You know, if you really wanted to do it from start, you know what I would do is take like a saw.
Take a
and
street
I would
saw.
literally cut the dirt on the lines, and some of it would be
That's not a bad
rock.
idea.
It wouldn't be a terrible idea, actually, but it's hard. Even walking the machine in to get to a starting point, you're driving over the lines, and they get smeared a little bit if the machine has to turn, and there's just no way to perfectly preserve our lines throughout the digging process. There's a little bit of guesswork, and so now we're just taking that guesswork out. We're making sure it's perfect as we can possibly make it. And also, I think we're gonna double check the height of our grade pegs that establish the top of the footing, because there was a lot going on out here. We had multiple readers on the same laser. Stop it, I'm trying to talk, shut up. After double checking the height of these grade pegs, I found that only about 2 out of 50 or 60 were low, and they were low by less than 1/8 of an inch. So I just doubled up the pegs. I drove a new one right beside the old one, and then checked it with this to get it just right.
Yeah.
We're all feeling a little baked here from the sun, and it's starting to take effect. I don't know. Say it again. Hey.
Jamie's given us the go-ahead to go ahead and lay the steel in this half of our footing here, this half of the structure. And we're doing 3 rows per our engineer's recommendation that's doing our suspended slab engineering. Problem is, he wants them 3 inches from the outside of the footing and the center, and none of our rebar chairs are really adding up to doing that. You can see we got these, which are, I think, made for a 16-inch wide footing.
That's right.
And we have a 24-inch wide footing. So you can see those 2 outside bars would not be 3 inches or even close. We could do 2.
I want them right about there and there. I think we're gonna do 2 metal bars, and then in the footing that's underneath the load-bearing parts of the suspended slab, we're gonna use 4, and I think we'll just use 2 of these, just like that.
Yeah.
In the wider section.
Got a new tool here, the auto rebar tire, and I broke my cardinal rule of buying a cheap tool, even though it's still $450. And I bought it because their good ones were like $3,000. And I thought, surely at $450, this thing would work amazing. And it works okay if you get the feel for it. It's a little fidgety. So I think our homeowner here who does some concrete work is gonna buy one and loan it to us, sadly. But this one's gonna work for just getting things sort of tied together here in the footing. Why are we using a ball of string like this?
Well, things are getting stupid already because I already used 4 rolls of string and I meant to buy more. But then I was like, I was even at the store today and I was like, nah, we don't need any more.
Here's a look at what we've got going on with the steel here. And if you're just casually watching the show and don't know about construction a lot, the reason we're adding steel to concrete, which is already really strong, is because concrete is not strong in tension, which means if the concrete gets bowed down like that, the bottom is gonna wanna crack and pull apart, but the top is in compression it's not gonna crack. So that's why the steel is near the bottom of the footing, to keep it from cracking apart if there were a soft spot somewhere in this dirt. What the heck? That goes there. This is like a puzzle, Jono. Jason's come up with a pretty great idea here. He's masterminding all these bends and having to measure each piece and tell them where to bend it. What you got?
Yeah, I was kind of guessing before on where I wanted the bend to be. So I'm like, well, when I just get some paint, I'll just throw an angle in there where the pivot point's going to be. And then I have something that I can measure to.
Look at that. Wow. Nice work.
Yeah, thanks. It's not just a hat rack all the time.
We're taking a vote here, so leave in the comments whether you'd rather look like me on the job site and not have a burnt neck, or look like Jason and have a burnt neck. Because he just said he'd rather have a burnt neck than look like me.
Sometimes looks are important.
We got a super highway of steel here, and it's heavy. And if we slide just one of these chairs in at a time, it's just smashing it flat. So Max and I are gonna kind of try to lift it up and let Ray slide like a bunch of these in. Is that a plan? That's the plan. That's the plan. All right, so. Yep, just. Oh, this is it right here. Yeah, just go crazy, Ray. We're waiting to do this because while you're tying it, if you step on the steel by accident, like walking around, it does just smash these. And then they're like tied to the steel, and then it's a real pain to get them out. You look like you've been digging in coal.
I'd probably rather dig coal than what we just did. Did you say rather? They got a blister here.
Dude, Jono's from England. He can say rather if he wants to.
Oh, did I say that wrong?
Rather?
Is that not what they say?
Rather?
Rather? Rather?
Rather?
We're gonna let Max try a couple of the whirligig ties, and I think it's called a tying tool, technically, not a whirligig, but I mean, look at that.
Whirly.
Oh, what else are you gonna call that?
No.
I mean, yeah, whirly bird. All right, so he's gonna get a little pre-bend on the tie.
Okay.
Put the loops together. Insert whirligig and pull and spin. Now you gotta stop before it snaps the wire. That's fine. That's beautiful. So we've got all of the steel in the footings except for right there, because we need to put a sewer sleeve in, which is going to be a 6-inch pipe at a certain elevation so that later the sewer line can run under the footing and out here to the septic. And Jamie did some math on how much fall we needed from way down there to here. So how deep does it have to be?
I actually just asked the plumber.
Oh.
But anyway, I'll give you the math. So the absolute minimum fall for a drain in a slab like this is 1/8 of an inch of drop per foot of travel. I think 1/4 of an inch per foot is maybe average or ideal. So maybe somewhere in between there, since it's really long distance. We have about 80 feet to travel from the first or the farthest one to the exit point right here. And so my plumber told me he needs like 24 inches from the top of the slab to the top of the sleeve.
Okay.
That's what we're going to shoot for.
Top of slab to top of sleeve.
Top of slab, top of sleeve, and then from here they can dig as deep as they need to get the fall down to the septic tank, wherever that might be.
Yeah. We are back at the job this morning, and our goal today is to get everything ready with these footings to pour concrete in them tomorrow, including getting them inspected so that we know they pass.
It seems like it'd be pretty cut and dry standing these J-bars up and bracing them off for the foundation, but it's actually kind of complicated. I heard that if you put them in the wrong spacing, they will interfere with the little cross ties that connect the formwork to itself to keep it from spreading. So if they hit, they're in the way, then you need a shift layout of your J-bar spacing, which is 16 inches on center, by the way. But the problem is that every wall segment does not land in an even 16-inch increment. Therefore, the starting and stopping points won't end in an even 16 inches. And I don't know how the corners of these forms start and stop And this is really, it's not confusing, but there's a lot of factors I'm considering. And maybe I'm just going nuts about it, and I shouldn't even think about any of it and just put it in. But also, I got to tell you this, it's a little frustrating to get these J-bars to stand up. Look at this one right here. I've got the first one. That is, it has some ties on it here, and I need it to stand up right there, 5 inches in and 5 inches in, but it is completely like unsupported right now. So what I'm doing is I'm cutting some braces. Actually, there's one right there, a little 4-foot piece, and I'm gonna actually brace it down to a peg right there. I'm gonna brace it down to a peg right here to get each corner. I've got to go around the whole place and do the corners like that as my starting point. And then we can go 16 inches on center from one side or the other.
Yep.
And that'll buy us a little time because I'm waiting on 4 people to call me back to try to get an answer. And the inspector's coming in a certain time, so we're in a rush.
Chill out, bro.
I'm trying, dude. I've got a lot going on.
Yeah. We did get a better rebar tie, automatic rebar gun. Thank you, Brock, for picking that up. So we're gonna check that out. How much was this thing? Like $2,000?
Yeah, here, why don't you go ahead and give it a little test right there.
Fingers clear.
Go ahead. That's all there is to it.
Okay, that does work better.
Yeah, yeah. Yeah.
Okay.
Yeah, so
buy
we
better
are gonna,
tools.
we're gonna borrow that. That belongs to him.
It's interesting, this does use the same gauge wire as the less expensive
It does.
one. I thought that might be different, but it hasn't jammed at all, and it does have a wider jaw, which is allowing me to get around some of these packed out places a lot easier.
Okay, give me a couple ties right there across the crossbar.
We're going to take a quick break from building to thank our sponsor for today's video, Keeps. And they've been a longtime sponsor of our channel. I would call them a channel partner at this point, so thank you, Keeps. And I've been personally using Keeps to help turn around my hair loss for about 2 years now, and it's really worked well. So with Keeps, you can get professional help for your hair loss right from the comfort of your home. You don't have to drive to the pharmacy or to the doctor's office. Just jump online on their website, fill out a few things. They'll hook you up with a provider and figure out what you need to help treat your hair loss. It'll come to your house in a discreet package, and you can get up to a 12-month supply at a time. Takes just seconds a day for me to use it. So it's been a great experience, and it's really worked well for me. Keeps has the only 2 FDA-approved medications for hair loss in men, and it's shocking how many men have some kind of male pattern baldness. I think the numbers are 2 out of 3 guys if you're over the age of 35, which is most of us. So if you want to get started and start keeping your hair instead of losing it, just head to keeps.com/Perkins. That's KEEPS.com/Perkins. There's a link in our video description as well. They've got a special offer for you. Thanks again to Keeps for sponsoring our video and for the free product. Let's get back to building.
So there's got to be a cross piece every 3 foot.
Okay.
So what we want to do is make sure that it crosses all the pieces of steel so we can tie it, but we don't want it to hit the bank, obviously. So I'm just going through and measuring what's a good number that will stick out far enough to tie in, but not hit the sides.
Nice. Are you cutting each custom?
No.
Just like 10
just
or
taking
something.
an average throughout all of
Okay.
them.
You can see we have the horizontal leg of our J-bar tied underneath of this outside row of rebar. It's going to help resist the rebar pulling up like this. And in this situation, the tension side of the wall is that side. The backfill is going to be on this side. The tension side, or the side that would want to actually split apart, is over here. Now on a retaining wall, it's actually the opposite. And I think you would put the J-bar leg going that way, because in that situation, the earth is wanting to push the wall like that because it's not braced at the top, and the tension side would actually be the earth side. It's pretty interesting that it's totally different because this is going to be braced at the top by the floor system. Another thing we're doing is putting in this giant sewer sleeve, and it looks like Jamie cut apart part of his shop ducting is what I would guess, to get this piece of pipe. Did you take something apart to get this pipe?
Oh, this was a piece of a gutter extension I made for the last job where we had water pouring out into backfill.
Oh, okay.
Yeah, so that's why there's a piece.
I was like, what is this?
When you see heating and air and plumbing stuff taped together,
It means Jamie did
something's
it.
going on. Something good, too. I believe this is the best position for this pipe. It points toward the septic system. That's pretty important. But also, we have some load-bearing footings that will be poured in a monolithic slab that actually come right here beside it. So I don't want this to be underneath a load-bearing point in the house.
Good idea.
with that said, we're putting it underneath the footing right here.
But we're gonna run 3 rows of rebar
But
across it.
Yeah, it's crossing perpendicular. Should
be fine.
Stick there.
Woo!
Whoa.
That was exciting.
I was watching some videos the other day of people throwing darts with their buddy who has their hand on the dartboard, and like a dart went right through his finger.
Great buddy. All right, cut. We've got our pipe sloping downhill and a stake at each end so that we can find it later. Now he's gonna carefully, he's getting the nice soil there, and he'll just start sprinkling it on and bury it nice and gentle. Jason and Ray are forming back the edges of our footing here so that the concrete doesn't pour over top of the ends of our sleeve here. And that would be a bad deal to try and find the ends if that was the case. Hey Jason, stick a grade peg right there, buddy.
Dude, my grandfather, Stephanie's grandfather did that right through the sewer line at their little cottage. Was putting in like railroad timbers.
Yeah.
Pounding it down, and Jeff, her brother Jeff lived there for years. Man, the sewer's always getting backed up. So I had a guy come out there with a snake.
Yeah.
He's like, there's something inside your pipe. So we dug down, little 4-inch pipe, piece of rebar right through the center.
Dead center.
Dead,
just a big old snag.
Just a big old poop snag.
All right. We just had the building inspector up here on the footing and the steel, like the rebar in our footing, and we passed, and it's pretty interesting how it all works. We have a set of plans here, and they are by an architect, but they're not stamped. They're not sealed, okay? Which means that we don't have to follow these exactly as long as we are following the building codes for building this building. If they were sealed, we would have to follow everything in this like to the T, no matter what. Now, we also have some engineering that's been done on this foundation, and the engineering supersedes all of that. So the soil was number one, right? Is engineered. So he did take his probe out. He did the thing. He tested for compaction.
Like any good
person
would do.
Yeah, and it seemed fine. But he said, you know what?
It don't even matter.
It don't even matter. I'm just doing this because I drove up here, right? So he did it just to do his due diligence. But he said, you got to send me the paperwork by the engineer that says this soil is good to build a house on.
That's right.
So that passed, and that's just the end of it. Now the steel, we passed. You know why?
Why?
Because there's no steel required by the North Carolina Building Code for this particular type of structure in this area.
It don't even matter. We could just drop it in there.
Yeah.
It would do no good, of course, but that's just to prove the point, I guess. Fantastic. Well, I think we're doing a great job with the steel.
Yeah, no, this is the best steel job we've ever done.
It is. There is no doubt. And I'm very happy. I'm very much thinking I'm going to sleep good at night.
Yeah. He did also show us some of the appendices
in
the code book here in the back that let us convert like our spacing on our J-bars. In the code book, it said 28 inches spacing for number 6 rebar for the J-bars. Well, we're doing
That's right.
number 5 J-bars on a 16-inch spacing. So he showed us where to convert that. Or
did you do that yet, or do we need to
No,
look at that?
well, it's engineered.
It is
that
engineered.
part is engineered, so that supersedes everything. You see where I'm going with this? It's
I see
complicated
where you're
to
going.
know what the real end of the line, what's the answer is. And he also, and I've never had this done in 20 years of building.
I'm listening.
He gave me what he called the trump card, okay?
Okay.
And the inspector gave me this. This is if
What a guy.
we're having like a real issue where we think that some sort of inspection determination was wrong.
Yes.
And they're telling us to do something that we don't think we need to do. And we really honestly are like, the inspector has made a mistake.
Yes.
We can file this with the state with the inspector's number on it
How about that?
and basically do an appeal. Hey, do we really have to do this? Is the inspector right or am I right? And I'm pretty impressed that the inspector himself.
I like this guy. I like him. And he's been super nice. It's actually, I was a little bit worried because we're working in a county we don't typically work with. And we don't know the inspectors and they don't know us, right? So, you know, it could go, we don't know which way it's going to go. It's been good, though. Really good. So I'm happy about that.
One thing that just came up in these notes, which, by the way, the inspector said is one of the most important parts of a plan. We have a lot of notes on this one. We just had this come up of what is the soil bearing capacity needed for this plan? And it's 1,500 PSF.
Pounds per square foot.
Yeah, so we're going to look at whether the engineering was that, and we know it was. But that was a good question, a good thing to look up in the notes. We got to pause here because Jason is convinced that these bars are somehow magnetized. These crossbars.
I'm just telling you, when you put it down and then you just give a little pull, I'm telling you, it pulls down like this one is sucking.
Now, I'm not usually into believing this type of stuff, but I did actually try it, and there's something a little
Try it.
weird with it. Let me try
Go
it.
nice and easy. Pick up from the center. Nice and easy.
You got to put it back down and pick it back up.
You might be right.
Yeah.
Something feels weird.
I'm telling you, something's not normal.
Don't stay out of my truck.
So we're taking all of the verticals and attaching them plumb to our top rail first. That was the first thing that was saving us time. And then to save time on getting these 5 inches out, we measured what our thumb to index finger tip was. It's about 5 inches. So basically, if we can do that, that's what we want, and we're tying the bottom. Jason's actually super worried that we're not gonna get this done by the pour tomorrow, which I think we're fine. All right, Max, let's see if you can get your feet in here. Not right there.
Not happening. Not happening.
We're on our third re-spool here, and we got it down to a science now. We're both sitting down,
3 of us.
one-handed, just going crazy.
Whoa. Get out of here.
Got to go all the way around, bud.
Can't go that way. You'll cave in the wall.
Same mower since 1998.
All right, I think this is the last one. Wow.
Wow.
Why were you worried? You're like, we're not going to get this done by noon tomorrow.
Because I had to get done with my job and come in and help you finish up yours. That's why.
All right.
It wasn't for Ray and I, dude.
Half the crew was on their phones or
Yeah,
sitting
y'all
over
would have
there
been
in the
over there in the
shade.
corner still if it wasn't for Ray and I. Come and save your butts.
Wow.
Welcome to the footer here. Happy graduations. Graduated to the footer.
So I think we have all the steel in, everything good to pour. What do you think?
Looks good. I mean, the only thing I'm wanting to check is make sure that we didn't lay the house out completely backwards facing the bank or something. I think that would, you know, be a pretty bad change. That's kind of a joke, but actually in the neighborhood where I live, they set some modular houses and they actually did set them backwards. And so the layout and the view side and the windows, it was all messed up, but it was actually too late because the cranes had already left and there was no way to pick them up and switch them around. So they just lived with it, whatever.